So in this equation, it says I'm going to use this graph to determine how much KBr was dissolved in 100 grams of water. And of course, that makes sense because this chart is per 100 grams. And then I'm going to use it to figure out vapor pressure. So here's my vapor pressure equation that I've written out. And it does give me this, which is my pure. So there is a step in between using this graph and using this equation that I kind of have to infer. And that step is that I need to take those numbers, that 100 and whatever I get for KBr, I'm going to have to convert it into mole fraction of solvent. And again, make sure you're paying attention and doing the correct one. So that means that I'm going to need my moles of water, because that's my solvent, got a lot of water in there, over, and it's total moles, but I'm going to write it as moles of solute, which is KBr, plus my moles of water. Because if I write it that way, I can just copy and paste my number down for my water. So I'm going to come over here and I'm going to say that, let's say that this is about 30. So probably this is about 25. And remember that I'm talking about KBr, which is that line right in there. So I'm going to try to just go up. And then I'm going to go over, and your homework and quiz and stuff, they've got a range of values. I mean, you need to be somewhat realistic, but I can't quite get that line to straighten out. So I just know the number's a little tiny bit lower, but it's around right in there. And then this is 80. So I would say that might be right around like 70. So I'm going to go with 70 for that one. So following my mole fraction right there, I have 100.0 grams of water. And then you should have the molar mass of water memorized. If you don't, do it. That's in 1 mole. That's going to be my numerator. And then I'm going to use this for part of my denominator. Right there. And I'm going to add to it my moles of KBr. So I had figured out that I had 70.0 from the chart of KBr. And then I need to convert that using the given molar mass. So there's that many grams in 1 mole of KBr. Just scooch that over a little. So that will be my mole fraction number. And then when you get that number, it just needs to be multiplied by the pressure. So it would end up being this 23.8 millimeters of mercury. Notice that since I'm starting in millimeters of mercury, it's going to come out in millimeters of mercury. And so it's going to be that times this whole thing. I like to try to put it all in my calculator at once because then I don't end up with rounding errors. And also, like, if I make one little mistake, I can go to the whole thing and fix it instead of trying to find the line I made the mistake on. So now I'm going to bring over my calculator. And I've got 23.8 times parentheses. And then I'm going to do a 100 divided by 18.02. That's the top part. And then divided by, and this I am going to need parentheses. And so I've got 70 divided by 119. So that parentheses plus 110 divided by 18.02. Parentheses close. And I'm going to do a double check because it's really easy on, on all of these to accidentally, just put this in wrong. So 23.8. Got that on top. I've got a big parentheses around the bottom. And so I think that looks good. And so that number is 19.7 millimeters of mercury. And I want to point out that this is a really, really low number. And first of all, it is lower, which is what should happen. Your pressure, vapor pressure, will decrease for solutions compared to the pure alone. So that's good. And then the other thing is that normal room pressure is 1 atm, which is 760 millimeters of mercury. And so when you're looking at this, you're like, well, that's not very much pressure, but that would make sense because we're just looking at room temperature water. It's not like the water is boiling and creating very much vapor pressure. So keep that in mind too.